Hey, this is Mr. Ward, and this is Algebra Do Now 25.2. And you started the day just like any other day, trying to mix two solutions of dangerous acids to get just the right mixture of acid. The acid in question is hydrofluoric acid, and I promise you most chemists are afraid of it for good reason. It's quite lethal, quite dangerous, and really hard to contain. It cuts through glass. So that's all right. You wanted to mix some that was 25% hydrofluoric acid with some that was some amount of 11% hydrofluoric acid. And in the end, you wanted 109 liters that was 16.5% hydrofluoric acid. So you got this 25% solution and 11% solution. You need to mix them together in some amounts so that you get 109 liters that is 16.5%. So what are the two key unknowns? The two key unknowns are the amount of a 25% mixture or solution and the amount of the 11% mixture. In chemistry, we call these solutions. Okay, I'm going to call this X, and I'm going to call the other one Y. Okay, and so those are my unknowns. I'll put an equal sign here. There we go. So this is really dangerous stuff. So, don't do this. But let's say you were doing this. So you came up with the right amount of 25% hydrofluoric acid and the amount of 11%. So you came up with those amounts as the unknowns, then you got it. So let's create a couple of equations. Now there's a simple equation we can do, which is just X liters of hydrofluoric acid at 25% plus Y liters at 11% will equal 109 liters at 16.5%. Now our other equation is a little sneakier. So this one is just the simple totals. The other equation, we want to know the actual amount of pure hydrofluoric acid that's involved. Well, 25% of the first solution, however many liters that is going to be hydrofluoric acid, and 11% of the other one will be, and that's going to equal 16.5% of the 109 liters will be hydrofluoric acid. So you can actually put all that stuff together and come up with a nice equation. I'm going to convert the 25% into 0.25 and the 11% into 0.19 and this 16.5% into 0.165. And now you have two equations that will get you what you need. So let's go to the next thing. Oh, there's no concentration of hydrofluoric acid, which can be relied upon as being safe, and there's no material that's completely resistant to degradation by hydrofluoric acid. In other words, you can't contain it. Whew, dangerous stuff. So here we go. Let's go into Desmos and work this out. So we got X plus Y equals 109, and then we've got 0.25X plus 0.11Y equals 0.165 times 109. And let's go and see what those graphs did. And there we go. Okay, so it looks like we've got about 42.821, which is approximately 43. So I'm going to say 42.821, comma, let's click on that point one more time, and then we've got 66.179. 66.179, and I'm going to go ahead and label that. Okay, so this is the point, so we'll label that. So let's get rid of some of that notation. Left, right, whatever. Okay, so here we go. We've got 42.821 liters of 25% solution and 66.179 liters of 11% solution. And that is going to be the solution, get it, of this system of equations. So here we go, is the solution, because makes both members of this system true. Okay, so that's one way we can solve it. Here's another way we can solve it. We can actually take this simple equation, x plus y equals 109. We can rearrange it to be y equals 109 minus x, or x equals 109 minus y. I'm going to pick just one of those. I'm going to replace y with 109 minus x in this equation. So I'm going to take that, and you should try this. I'm going to take 0.25 x plus 0.11 y equals 0.165 times 109. And I encourage use of calculators when you're working through this because it does involve some decimals. We're going to take this equation and we're going to replace this y with 109 minus x. And we're going to solve this whole thing. It looks pretty ugly right now, doesn't it? Well, it is. I'll be honest. I'm going to go ahead and say 0.25x, and I'm going to say 11 times 109. Well, that's going to be 109 plus 1090. So we can put that together. That's going to be 1199. So that's going to be plus 1199 minus 11x, or 0.11x, I should say. And I actually messed up my decimals because I forgot that I'm dealing with a decimal. So that's going to be 11.99. Okay, so it's 0.25x plus 11.99 minus 0.11x. And that's going to equal 1.165 times 109. So I'm going to go into Desmos and let Desmos do that. 0.165 times 109. And I get 17.85 equals 17.85. Now you may remember way back in the Wayback Machine a little thing called clearing the decimals. Well, each one of these things has two decimal places, so I'm just going to get rid of them. I multiply everything times 100. That becomes 25x. That becomes 1,199. Subtract 11x equals 1,785. Combine my like terms. 25x minus 11x will be 14x plus 1199 equals 1785. And now I will subtract 1199 from both sides. And that's one less than taking away 1200. So that actually makes that math really easy. 14x equals, well, 1785 minus 1200 would be 585. But I took away one less than that, so it's 586. So I've got 14x equals 586. Now I'm going to divide both sides by 14. And x is going to equal 586 divided by 14. Let's see what that equals. Go to the calculator and let it do its thing. It equals 41.85, which is pretty close to what we got here. So I wonder if I had a calculation error along the way. I'm going to check that. And it does not appear, so there's probably just some sort of rounding error happening along the way. So I'm getting 42-ish for what x equals. And earlier I got 42, so pretty close. So I am thinking I have a minor calculation error along the way in here. But we have a pretty close answer. As you can see, I am not a fan of the substitution method, but it is an important method, and there's a lot of things to keep track of along the way. So I'm just going to double check here. 165, yes, I didn't copy anything wrong. Okay, well, I'm going to accept that as close enough for right now. About 42 liters by this calculation. And then cleaning up later, I will sort that out. Once we have that information, of course, we can say y equals 109 minus 42. I'm just rounding that since I know there's an error in there. And 109 minus 42 is going to be 67, which is fairly close to the 66 liters that I was getting earlier. I am still finding these numbers slightly sus. I'm pretty sure I had a minor calculation error, and I'm not going to take up your time too much more on that, but I'll take a look at it. At any rate, this method will at least get you close, and if you don't make any calculation errors along the way, then you should get the right answer. So I'll leave that mistake in there. I hope it doesn't bother you too much. I'm acknowledging there's a mistake, and I will find it.